In his DDD book, Evans included a really useful diagram of how many of the concepts and patterns of DDD are interrelated. Let's take a look at that mind map.
Evans refers to this as a navigation map, and it lays out all of the pieces of domain-driven design and how they relate to one another. We want you to see it so that you have a concept of the big picture, even though in this course we'll spend most of our time on a subset. We will be defining many of these terms later on in the course, so don't panic. We've mentioned modeling the domain and subdomains a few times. Modeling is an intense examination of the problem space. Key to this is working together with the subject matter experts to identify the core domain and other subdomains that you'll be tackling. Another important aspect of modeling is identifying what's called bounded contexts. And within each of these bounded contexts, you focus on modeling a particular subdomain. As a result of modeling a bounded context, you'll identify entities, value objects, aggregates, domain events, repositories, and more, and how they interact with each other.
In the image, there's more than just these subdomains, however. For example, there's a concept of an anti-corruption layer, which allows subdomains to communicate with one another from behind their boundaries. The model also has notes for each element, such as free teams to go separate ways. This is something that can be accomplished once you've identified the boundaries of each subdomain. Or, avoid overinvesting in generic subdomains. That could be something like a credit card verification service that you could choose to use rather than building yourself. As you begin focusing on specific subdomains, another very important DDD concept surfaces, driven by the need for clear, concise communication. It's called the ubiquitous language. A simple definition of a ubiquitous language is to come up with terms that will be commonly used when discussing a particular subdomain. And they will most likely be terms that come from the problem space, not the software world. But they have to be agreed upon so that as discussions move forward, there is no confusion or misunderstanding created by the terminology used by various members of the team.
We invite you to pause this video to look over this map and read the notes associated with the various elements and contemplate what they might mean. We'll revisit this throughout the course, and we hope that the map will make more and more sense as you work through the course.
Now we want to switch over and show you a relatively small DDD-based solution that we'll be working on for the rest of the course. This app represents an appointment scheduling system for a veterinary clinic. It's small, in air quotes, but since DDD requires a certain amount of complexity to warrant its use, it's bigger than most demos you'll see in other courses or presentations. For this course, we decided that we would use a veterinary clinic management system because it has a decent amount of complexity, and that means that we can apply some of the DDD principles, but it also gives us an excuse to show off pictures of our pets.
And our friends' pets, too. We got a whole bunch of pet pictures from other Pluralsight authors in here, and they're all so cute.
We've got Ben Franklin here from Michael Jenkins. We've got Patrick Nieborg's dog here, Sugar. Aren't these guys cute? And, of course, Julie's got Samson.
Oh, my handsome boy.
And I've got Darwin, the silly poodle. He was just a puppy when we recorded the first version of this course. And he's got a new friend, Rosie. Rosie's just a puppy. I guess every time I get a puppy, we have to update this course.
So the idea behind this application is that if you're working at the front desk of a vet clinic and someone walks in, maybe they want to schedule an appointment, or the phone rings with someone who wants to schedule an appointment for their pet, the first thing you're going to do is look that client up, the person, in the system.
So the user starts by looking up the client, and from there they can choose which of the client's animals or patients they're going to schedule. So here's Julie with Samson, here's Kim with Roxy. Next, the user's just going to click on an open slot in the schedule, which opens up the Create Appointment window.
Oh, Roxy, you're such a cutie. We can set up Roxy for a wellness exam with Dr. Smith.
Now, notice before we save this appointment, it isn't yet confirmed. We'll get to that in a minute. So we save, and the appointment shows up. Now, the complexity in this system comes into play when we have to do some checks for certain things. We want to make sure, for instance, that Roxy isn't already scheduled in one of the other rooms at this exact time. We also want to send an email notification to Kim to let her know that Roxy has this appointment scheduled. We'll add a link in the email the client can click to confirm, and in a real system, perhaps it would add it to their calendar of choice. The idea is to cut down on no-show appointments for the clinic.
Of course, there are other features of this application. We're focused on the schedule right now, but we do need to be able to manage client data and manage their pet data, the clinic's patients, and things like that. Admins need to be able to manage doctors and rooms and appointment types, since these all might change over time or from one clinic to another that uses the same software. But those are mostly CRUD tasks, which means we're just talking about adding and removing records and maybe making some edits without a whole lot of complexity. We'll talk about those tasks in a different compartment of the application than the schedule, which of course has a lot more complexity.
So why don't we take a look at the structure of our app. This is a distributed application built with ASP.NET Core on .NET 5. It's running Blazor WebAssembly in the front end, which is talking to APIs running on ASP.NET Core. There are 3 different web apps that the system uses. 2 are used internally by client staff, and then there's the public-facing website for the clinic, which is needed for the confirmation links that users will click. The 2 clinic apps, Front Desk and Clinic Management, each have their own database, and all 3 apps communicate with one another using messages transported by RabbitMQ. Like I said, it's maybe a little more complicated than most demos. We want the sample app to be something you spend some time with and extend as part of your experience with this course. So please be sure to check it out and run it locally. It should just work if you have Docker installed.
Now let's take a quick look at how the code is organized. The full solution is hosted on Steve's GitHub account. Here's the URL, but we'll definitely also have that URL in the resources slides at the end of this module. Pluralsight DDD Fundamentals is the name of the root of our GitHub repository. In here, you can see the 3 web apps, Clinic Management, Front Desk, and the public-facing website, Vet Clinic Public.
There's also a folder for shared kernel, which we'll talk about a little bit later. The first app we're going to focus on, though, is the Front Desk app.
Our main focus for this course is going to be the Front Desk application and its scheduling functionality. Looking at the solution, you can see it's broken up into 7 projects, which seems like a lot, but 3 of them are just there to support Blazor. The server-side code, where a domain model resides, is just 3 projects.
The most important project is frontdesk.core. That's where the domain model is defined. All of the app's infrastructure needs, like how it talks to its database or RabbitMQ, are kept in the frontdesk.infrastructure project. And the front end, in this case ASP.NET Core and its API endpoints, is in the frontdesk.api project. This is the front end from the server's perspective. The system is using a clean architecture design, which you may also hear referred to as onion architecture or ports and adapters. I cover this in my N-tier applications in C# course, and I have a popular GitHub solution template you can use to set up a new project using this approach.
With clean architecture, the project dependencies all point towards the domain model in the core project. So both the API and infrastructure projects have a dependency on core. Core should never depend on infrastructure concerns, but it can leverage NuGet packages that don't couple it to infrastructure concerns.
In this case, it's using a couple of utility packages, as well as the shared kernel package that's shared by other apps. We'll talk more about shared kernel later. The Clinic Management app uses the same kind of structure and also has a Blazor front end because why not? It's pretty much just CRUD, so we don't focus too much on its domain model, but it is a distinct app with its own database, and we do need to build into our design a way to propagate changes from it to the Front Desk app.
Finally, there's the public web app. It's just one project, and it's pretty simple. This is responsible for sending emails, which this demonstration fakes using a tool called Papercut, and it hosts the link that clients click to confirm appointments. The public web app also needs to communicate with the front desk, but it doesn't have a database of its own, nor does it access any of the other apps' databases.
That's it in a nutshell. We'll demonstrate the confirmation emails and more complex use cases later in the course, but for now, that should give you an idea of how the ideas we're sharing are put into practice.
So as we've talked about Creating applications is not about writing code, even though often that's a really, really fun part for us developers. But it's about solving problems. And the more complex the problems are, the more difficult the whole project becomes. So domain-driven design gives us some great patterns and practices for attacking these more complex problems. And they get us to really focus on interacting with the domain experts, breaking apart our domain and working on things in smaller units and in a very organized fashion. And in the end, it gives us a much more efficient and effective path to success in creating our solutions.
Yeah, we talked about some of the benefits that domain-driven design provides, as well as some of the drawbacks. Specifically, your team just needs to know domain-driven design, and your domain experts need to be available to work with you on these systems. Domain-driven design is a big topic. We looked at some of the different concepts that are involved in DDD, and we're going to look at a lot more of them in depth through this course. But remember that this is just an introduction to domain-driven design, so some of these aspects that are a little more advanced, we're not going to be able to cover with a great deal of depth.
In the next module, we'll start exploring the process of discovering and modeling domains. Here are some links to resources that we mention in this module and others that we find relevant.
This is Steve Smith.
And this is Julie Lerman, and thanks for watching Domain-Driven Design Fundamentals.